Welcome to the Data Driven Manufacturing Podcast, where we explore how data is transforming the manufacturing world. My name is Rowan Easter Robinson, and I'm an engineer at TrackMyMachines. I'll be talking in every episode to engineers, business owners, and professors who are leading the way in data-driven manufacturing. Let's get started. And so I'm here with Carl Parry. Welcome to the Data Driven Manufacturing Podcast. I'm really excited today, Carl, because you're the first customer, TrackMyMachines customer we've had on the podcast.
Yep.
So thanks for agreeing to come on in like a long form, open conversation. I know some people kind of might find it a bit hard to make sure they say exactly the right thing in 40 minutes. Yeah. So thanks for coming on.
No problem.
Hopefully we're going to talk not just about TrackMyMachines and how it's helped you, but just about your journey, because you've been here at Gardner Denver, I know, for a long time.
Yeah.
And I don't know if you're necessarily famous in the industry, but you're quite well known for making big changes. You've had massive positive impact here at Gardner Denver in Bradford, which is where we are today. And yeah, could you give us a bit of background of what you do at Gardner Denver now and what Gardner Denver does as a company?
Yeah, so I've been at Gardner Denver 11 years now. I'm the manufacturing engineer for this site in Bradford for the transport solutions. We manufacture all kind of products, air ends, full solutions for transport industry, really.
Yeah, and you've got a massive site, a massive kind of open space where there's loads of vans up high getting fitted with, I guess, compressors and electrical.
Yeah, all for the bulk transfer, liquid transfer of tankers. You have multiple disciplines of engineering within the facility as well. So
yeah, there's a big electrical department putting together HMIs and stuff, wiring stuff up by hand and other processes. And then you've got where you work mostly, which is CNC machining.
Yeah.
Yeah.
So yeah, we've got multiple disciplines, assembly through to laser, sheet metal processing, multiple machine tools. Again, some really high-tech equipment.
It's really, really nice to see how the company's changed since I came in first 3 years ago with TrackMyMachines. I knew you before, I think with Lee Rogers at Nikken.
Yeah, Nikken,
Yeah, and seeing the company change, you took on obviously fiber laser has been one of the most recent investments.
Yeah.
And seeing the machinery change and the sites move around. Gardner Denver is a big company.
Yes.
There's a lot of sites around the world, but at Bradford, you're doing really well. I don't want to say you're the best, but you're one of a really good site, kind of almost like a really great example of manufacturing here in Bradford.
Yeah, it's a large facility within Bradford. We used to be across two sites. We've merged into one now. So that was a great project on its own.
Yeah, exactly.
Challenging, but yet rewarding. So,
You've seen a big changes. How long have you been here, and what do you do now? What do you start doing?
So I started as a production engineer within the business at the other site in Bradford, developing processes, machine equipment, work holding, tool holding processes.
Yeah, really down dirty programming. Setting up with different vices, like if we grip it this way, we can do 2 ups rather than 3. Proper like process improvement.
Complicated work holding and trying to get that cycle time up, so you're getting the uptime on the machine.
Yeah, because some people think you want to get cycle time down, but if you multiply your components, you want to go up, but you get a better productivity.
Yeah, it's a smoother transition. It enables the product to flow better through the factory and making sure the machines are earning the money, really.
And what kind of components are these that you're making? So
case machining predominantly. Anything up to, we did some at 1200 mil high, all the way down to manifold blocks, kind of aluminium manifolds and small aluminium components. So there's a vast range of product really, but mainly aluminium and cast iron case machining really.
Yeah, absolutely. So there's aluminium, obviously you can push pretty hard, and you can work on, there's a huge range of kind of different selections. You can make PCD tooling or standard carbide tooling, but you've also worked on developing processes across big components to small components.
So yeah, we manufacture a range of products all the way through from, like I said, small manifolds all the way through to high-tech cases, very tight tolerance machining.
Yeah, when you're talking about making parts like this, what kind of volumes are we talking about? We're talking about a lot of volume every month. Yeah,
no, they're not great volumes. They rotate in terms of the volume capacity, so there'll be medium to small volumes, high mix. So it's very hard to plan your production through that kind of range. But with the products and we've got on the machine tool, the technology we have on there, it allows us to plan that production more efficiently.
Yeah, so you still need to have quick changeovers
Correct.
from one product to another.
Yeah, we have to have zero setup time as much as possible, where we can just alter products while the machine's running. We're either loading or setting, and the setting's very minimal. Quick zero positioning, work holding, and that kind of thing. So we have to make sure that the machines are trying to achieve the biggest amount of uptime we possibly can have, really.
It's interesting that as a product manufacturer, some people would think, well, you make the one machine makes the same part every single day for the whole of its life.
Yeah.
But even though you guys will have a standard set of products you're going to make every single day in terms of assembly,
Yeah.
The actual machining components needs to be reactive, it seems.
Yeah, definitely. We've got to have a balanced line across the machine tools and standardization across them. So if anything happens, which in all engineering aspects, things do happen, breakdowns, etc., well, we can pick a product up and move it to another tool with very minimal effort and continue to run that product.
Yeah, and that attitude, I guess, would help a small machine shop doing one-offs
Yep.
with 3 CNC machines, all the way up to a company like yourselves that have got some really strong CNC machines, loads of CNC machines, making products. You still need to have that reactivity and that quick changeover.
Correct, yeah, you've got to minimise that effort and that time it takes to get that product back into the machining.
Yeah, and so when you continued your kind of journey, starting as the process engineer right at the start of your career here at Gardner Denver, what kind of changes did you start to make, and what kind of improvements did you see?
So we started to look at the tooling mainly. You could have for a geometry of bores on an end plate. You might have 5 or 6 bores in there. Started to look at it. That's 5, 6 tools just for the finishing operation. If you want to semi-finish it, that's another 5, 6 tools. Roughing it. So we approached the OEMs, tooling manufacturers, hey, how can we get this down to a 1 tool or 3 tool solution? And we just turn in multiple bores into basically a drilled feature. And that brings your cycle time, improves your tool life as well, and stops the faffing around of engineering.
Yeah, absolutely. Which is, faff is kind of the biggest drain on not only resources but people's morale as well.
Yeah.
If you've got to change a big tooling package over because you're changing a part, that is it's faff, and someone's got to do it, and it's not necessarily an interesting job.
Yeah.
If you can reduce all that down and not have to change a 40 tool and package because you bring the number of tools down,
Correct.
you reduce faff. People want to do more interesting jobs, and it's really good for the people as well as the process.
Yeah, exactly. I mean, for example, one of the tools we've got in there has done 4,000 bores, and the guys have never altered that size, and it's an H7 fit.
That's amazing.
On all bore
And
tolerances.
that's a super hard insert, I guess, that's not wearing.
Yeah, it's different technology. It's just giving the process a more reliable process, but giving the operator faith, and he could be doing alternative tasks to make sure the uptime on another machine's met, not just concentrating on that one product, which is where we do the faff. He was altering 6 or 7 boring bars, keeping tolerances, tweaking, back to the presetter, back to the machine.
Which some people might say, well, that's my skilled job, I like doing that, but it doesn't need to be done.
No, it doesn't. He can use his skills doing other jobs within the facility to increase the uptime on the other tools as well. So
that's one thing I love talking to you. Whenever I call you up or you call me, I wish you called me more, to be honest, Carl, but you're always passionate and talking about the latest thing, whether it's literally changing one set of drills into a step drill, or you're talking about a massive capital investment in brand new machinery. There's passion, but not only passion, there's curiosity and investigation. I remember at one point you called me up saying, oh, we're looking at maybe want to do automated boring bars that change their diameters.
Correct,
and I've never seen that before. And you were like, oh, I want to try it. And
the technology is available. It's got to be realistic. Cost per hole and that kind of analysis has still got to be there. We can go to the nth degree, but is it practical?
Yeah.
It's got to be practical.
But you've been pushing, you've gone from, rather than a company that might say, we want to change, let's go from carbide to PCD.
Yeah.
You're going, let's go from carbide to, oh my God, let's try and get every board done with one boring bar that can change itself based on a macro. You're just like going right to the nth degree and then bringing it back. So you're exploring what's possible and then seeing what's viable.
Yeah, definitely. It's got to be viable. It's got to be right for the business as well, and it's got to be right for the product. If it's not right, then don't do it. But we've got to explore these possibilities because that's the job.
Yeah, that's how you stay competitive.
Yeah, exactly.
Yeah, and the world is changing. Costs are going up. There's a lot of competition around the world for work moving around to different countries.
Yeah.
So in this country, we have to stay competitive. We can't do that without making improvements like what you've been doing, hopefully, for the past 11 years and hopefully beyond. Cool. So what over these 11 years of experience in process improvement, which every company in manufacturing needs to do process improvement every single day.
Yeah.
What's some advice you'd help to try maybe how do they target faff? What bit of faff should they be looking at they can try and fix? What advice would you have for someone looking at trying to be more competitive?
Having the data available is key. Without that data to see which area of the faff is the easiest to chip away at first. Some things are out of our control. Breakdowns are out of control. If you've got maintenance providers, you've got annual servicing, things like that. If you've got them in place, then you're doing your best what you can to the tool. If it breaks down, that's out of your control. But what is in your control is your process. And having that data available identifies the process is not performing as well as what you thought. And that, it wasn't the case for us. When we got the data after 3-month trial, we was shocked. We thought it was great, and then we've said, okay, there's a lot to dive into there. So
can I be clear? I've not given you £20 to start talking about TrackMyMachines. That was purely natural. If you look at the video, you can see there's definitely not a £20 note passing between our hands. So you're talking now about when we first met properly, I guess, with TrackMyMachines, and you were one of my first customers.
Yeah.
I remember calling you up saying, I'm building a machine monitoring system. We want to measure up time, and you're like, that's something we really want to do. How did that journey start? How come you realised you wanted to measure this thing? And what is it? What is it that you're measuring?
Yeah, so like I said, we thought we had amazing uptime. We really did. We thought we was one of the most efficient businesses within the group, and we was doing really well. We knew we suffered from breakdown, but we couldn't prove it. So when we first analysed the data, when you approached us and said, "Hey, I'm developing a machine tool monitoring software," we was really excited. Yeah, we need this we need this now. When can we have it? We were really excited.
Really nice thing to hear.
And then we saw the data after 3 months, and we was overwhelmed with this data, and we said, right, okay, we need to act. What can we do?
And by uptime, we're talking about the machines being productive.
Yeah, correct.
The number of hours that spindles are turning, cutting parts, making components, making money, essentially.
Yes.
And why was it surprising?
Why was it surprising? Because we thought, like I said, we thought the processes were nailed and we had minimal downtime. When we actually reviewed the data, it was above below our expectations, I assume. So we had a lot of work to do.
Fair enough. And I guess having that shock of, you think your machines are maybe running this at this number of hours, because you'll have different companies manage in different ways. Some people work on labour hours, so how many people do I have available on the shop floor?
Yeah.
And that should decide my productivity. Other people say, well, I've got 10 machines, maybe I'm paying half of them on finance, they're new machines, they need to be making money, so those machine hours are the ones I've got available, they dictate my productivity. So how did you start to use the machine uptime to make changes and target changes?
We broke the data down into things that were in our control straight away. We looked at what was the most difficult to do, and that was machine tool breakdown. Some of the machines are aging, and we've spent a lot of money bringing them up to a standard. But things that were in our control was work setting, tool setting. Work setting is very minimal, but there's still an element of surprise there when we got it back. When we investigated it straight away, because you've got a time and a date, so you can track that in a machine number, so we can go to the machine, speak to the operators and say, hey, which job are we looking at, what's your problems, investigate it thoroughly, and then act on that accordingly.
Yeah, because you'd already invested a lot in the quick change plates that I've seen, which are fantastic pieces of kit, all made bespoke for the products that you do. And I guess after all that investment, you'd expect work changeover to be super quick.
Yeah.
But there's always the process, if you were to map out, there's a big long table, if you were to map out what actually happens from a purchase order getting raised by a customer to then parts going out the door, the process would be probably, with post-it notes, would be longer than this table.
Yeah.
So once you start mapping out, especially even just billet comes into the cell, gets produced, then goes back out again, there's a lot more that happens in that time than you really think.
Yeah, I mean, some of the tooling where we thought we had optimal tool life, we could monitor this in minutes. We then decided to create sister tooling. So where we were having problems, tools running out of life, stopping the process, we would then say, okay, it's now invest in a sister tool to continue that operation, to let that operator continue the uptime of the machine while he goes and sets a new tool life on the other sister tool. So yeah, it really pushed forward further thinking in how we can create uptime through managing tooling better.
Yeah,
so
exactly. So if you change your mindset to maybe the operator and the machine need to work in tandem.
Correct.
The operator has 8 hours of useful work. The machine has 8 hours of useful work. How can you get 16 hours of useful work out of both those people? But you treat it like a person almost.
Yeah, correct. And we've got to look at the lights out capabilities as well. So how do we manage a lights out scenario within this business? Do we need duplicate work holding where we run that through? Do we have alternative processes for lights out? So where we're not pushing it as hard to give us optimal tool life. So we might generate 2, 3, 4 hours on the equipment we had at the time, lights out manufacturing. So that's where you get that extra benefit, utilising the machine tools, and also multi-machine manning. With certain layouts that we propose, we can achieve multi-machine manning with one person. So you're tripling your output.
Yeah, absolutely. So there's loads of changes you can make as an engineering business to try and up that productivity. But for some people, it's clear that it starts with data. For some people, it's maybe not so clear. For those people who maybe don't see the value in measuring what currently is happening on a machine shop, why is data-driven manufacturing a crucial thing to adopt into like your process, into your attitudes?
We approached the operators and said, look, we're not tracking you, we're tracking the machines, and we want to make your life better. We don't want to make it a laborious process, and what data is available is something that everybody can use as well. There might be an aspect between 2 shift patterns where tool settings taking slightly longer on one shift. It's a repeatable process. You can see that downtime occurring. But on the alternative shift, it's extending. And it's a way of reaching out to the production engineers or production planners or management saying, hey, I need a bit of help. Having that interaction from the data and then to the other people within the business is key. Yeah. And we might have to put training programs in place, or we might just have to create a better SOP to minimise that downtime. So as long as you can see it between shift patterns, it's repeatable, and then you can act on it accordingly.
Yeah, absolutely. Developing standard procedures is so important for a manufacturing process, because a factory is a complicated place. If you don't have a process, you don't know what's happening. Yeah. You can't try and improve it. Do you think there's also value in just the fact that you have like a piece of truth data that everybody could talk about? So if there's an incident that happens on a Monday, an afternoon, and operator, manager, that maybe a director gets pulled in, you have some piece of truth that's, as well as people's stories that they can tell about what happened.
Yeah.
Is that value? Is there value into just having a piece of truth to talk around?
Correct. Yeah. I mean, we have daily meetings with the workshop team, and having that data available is one way of saying, okay, we witnessed a 3-hour set yesterday. What happened? And it prompting them meetings to discuss with the shop floor. Where are we? What's the situation, and why are we in this situation? So yeah, it prompts meetings every day, really.
Yeah, and there's because I think there's a lot going on. There's a lot of opportunity cost. There's a lot of cost people don't see, and if you bring that up, make it a number, make it visible, suddenly a problem that was latent, that was sat there hidden for 3 years, suddenly becomes available and possible to talk about. You can't talk about it unless you can see it.
No, exactly. And like I said, if everybody can read the data from basic dashboards and visualizations, that's key. I can interpret some data. Other people may not be able to look at that and interpret it in the same manner, but just having something that's clear and structured that everybody's bought into and created a downtime reason for, it's for everybody, not just for one person to present KPIs, for example. It's used across the whole facility.
Absolutely. And moving on to what's happening now. What exciting things are happening at Gardner Denver here in Bradford like today?
Yeah, so we are producing new products. So yeah, new product development, new product introduction, prototyping. So yeah, new processes, tooling, advanced tooling, capital acquisitions on machines. That kind of thing.
Loads of new projects. There's one particular project in particular, the big capital acquisition.
Yeah.
It's a huge amount of machinery. I don't know how much you can talk about it. Is it still a little bit?
Yeah, it's still
secretive. Okay,
yeah, so still NDAs there.
But it's a really big project.
Yeah.
And it's really exciting for you guys. It's probably a slightly different way to manufacture something. And how has data and being data driven helped with justifying such a big project?
Yeah, we could talk about uptime, downtime to our leadership teams, but having the data available physically to show in a period of time where are we weak and the areas that are weak. And again, I went back to the areas that are out of our control, machine tool breakdowns. As long as you've got things in place, you can show your leadership teams, hey, we've got service agreements, we've got service schedules, and at the end of the day, the machines are failing on us, and we need that investment now to secure the next 10 years.
So it's helping you to plan ahead.
Correct, yeah. And it gives you that fighting chance in being professional and showing that actual data.
Yeah, it's unbelievable to think really that if there's a lot of companies that will be trying to justify a brand new machine for more capacity to hit customer demand, and if they don't have some piece of data to show why they need that, everything is just an opinion. It's just I think we need to spend £300,000 because of this.
Yeah, and that was our scenario before TrackMyMachines. It really was. We had basic data from Excel spreadsheets. We had operators' opinions, my own opinions, production managers' opinions. We're saying, hey, we need help. We're struggling to do this. If I want a brand new tool, we'll justify it in minutes. Okay, I can do that. But then actually giving a cost per part discount on what we've just justified, it's huge for the business.
Yeah, absolutely. And you can't make a business decision without having hard numbers behind it.
Correct.
Interesting. Cool. So over your whole journey at Gardner Denver, you've gone from basic process improvement, talking about fixturing, work ordering, programming, really hard stuff. I guess you're still doing part programming today.
Yeah, I love it. I absolutely love it.
You're never going to stop doing that, I'm sure. But now we're talking about really big capital projects for the whole business, for the whole plant here at Bradford. Over that whole time, I think you've gained such a wealth of knowledge and experience. For manufacturing engineers that are looking to maybe take a similar path to you and want to end up managing huge projects in engineering, what advice would you have for them to try and to be the most valuable that they can be for the business, for the engineering business, and to make the most improvement, the most impact?
I think teamwork is probably one of the major things. You have to have a good, reliable team. If that teamwork is not there, you're going to struggle. You can't do all this on your own. It's just unfeasible. Focus and enjoy it. Get a passion for it. I've got a real passion for engineering. I love engineering, and I enjoy looking at something and saying, how's that made, and how are we doing that, and where's it come from, and then stripping it down to the basics and really pushing it forward in terms of, well, I can do this, and we could do it better, and we could do it cheaper. Leading big projects, it really is a team-focused event, and I'm lucky I've got that team behind me.
I think teamwork's a really good point. We have a bit of an attitude as a culture, maybe, of this is how we've always done it. This works. Why change?
This is the way we've always done it.
Yeah, it should have an acronym. We should have no. You just said that. That's it. Cancel. That doesn't count. That doesn't count. Try a different one. Yeah, try a different one. And I think you're right. The teamwork means you have buy-in from other people. Yeah. It means people care about what you're doing and want you to succeed. Without help from people on the shop floor, you can't implement changes.
Correct, yeah, and they're the data source as well as things like TrackMyMachines, machine tool monitoring. These are the guys that do that job day after day. And
they're your best mates.
You need to buy into them in their time and take their feedback and then approach them. Hey, what about doing it this way? What do you think? And then working with them together to establish a new process and then prove it.
Yeah, absolutely.
That's the most rewarding thing as well.
Yeah, so people are a massive benefit if you're trying to do data-driven manufacturing as well. Without people, you can't run the business.
Exactly.
Without people, you don't know what's going on in the business, as well as having all this software to help to track the machinery. You need to know what the people are doing.
Yeah, I mean, TrackMyMachine requires the operators to add the downtime reasons when it's there. And buy into it. And at first it was a kind of, are you tracking me? And I says, no, the name in the product is TrackMyMachines. We're tracking the machines to make your life better. Now help us, please, and we will push for new processes, new tools, new equipment. They were really keen on the data, and they were adding the downtime reasons, working with yourself and me and the production manager, and creating new products, processes, and yeah, it's been a real learning curve for me as well.
Yeah. It's a serious journey, clearly, for 11 whole years. That's brilliant. So yeah, we've had a really great overview of how you've gone from doing stuff in the trenches to still doing stuff in the trenches, but working on really big projects right now, and putting together massive business cases for huge impact, positive impacts in a really respected manufacturing company like Gardner Denver.
Yeah.
Thank you really much for your time, Carl. I really appreciate it. So yeah, that's been the Data-Driven Manufacturing Podcast. We've been talking about how data can help make a massive impact in your business and try and find out what's going on in the manufacturing plant, whether you've got one CNC machine, 10 CNC machines, or 100 CNC machines. You need to measure what's happening to then find out where to go next.
Yeah, most definitely. It's so valuable to anything within business, is that data. So, yeah, thank you for delivering such a simple and effective product.
Brilliant. Yeah, no money was transferred in the course of this meeting. Thank you very much, Carl.
Thank you.